So, last time we were together, we started chapter 9, which was a huge shift. So let's see how we're doing so far. What'd you get for number 1? We'll start with Catalina, Tristan, and then Sebastian. Okay? Okay? Okay. The correct answer is x squared plus 3x minus 11. Okay, so clearly we have a few issues that we need to work out. So we'll go back to that one in a moment. Number 2, what did you get as the solution? Jada, Sharik, and then Anita. Okay.
B is a 4 plus B cubed.
Okay. Okay, so all 3 of you agree on this one, and that is the correct solution. So let's go back to number 1. What is the difference for number 1 that makes it a little bit more challenging than number 2? What's the detail in number 1 that you had to pick up on? Catalina? Yeah, it's a subtraction problem, and so what did you say? We do what with it? We distribute it. You can think of it as keep, change, change. There's a few different ways of thinking of it, but here's what it ends up being. Flip the sign, and then flip the sign of everything inside. So double check and make sure, all my students who got it wrong, that that's what you did. Now we're combining like terms. So we have an x to the third and a negative x to the third. What happens with those two? Brandon? They just cancel each other out. So those disappear. And then we have negative 2x squared and 3x squared. When you add those two together, you get positive x squared. Then we have 3x. That's it. 3x. And finally we have a negative 5 and a negative 6. And that gets you the negative 11. Comments, questions, concerns? No concerns? Okay, put the warm up to. The last time we were together, we talked largely about how to communicate about the ideas we're going to be studying. Talked a lot about vocabulary, new terms. We did do some actual algebra. But we really used an idea that you learned in 6th grade and was reinforced this year, the idea of combining like terms. Because all we were doing last time was adding and subtracting. Today is when things shift quite a bit. You already have the vocabulary down, so there's not really any new terminology that's going to be introduced, again, at all. So now it's a matter of learning what you're allowed to do in certain situations. We're talking about multiplying polynomials. It is going to get a bit complex. There's going to be some specific area, one specific area where a lot of you are going to get repeatedly confused. And one of your jobs over the course of today and the next couple of days is to try and work out that confusion in your head and become proficient at what you're allowed to do depending on the operation. Okay? So if you would put your pencils down for a moment, because first I want to introduce and show you what we're going to be doing. Here is an example that's done completely. So we're multiplying 2 polynomials. This is a binomial, and that's a trinomial, and you can see that they're being multiplied together right there because they're next to each other. Okay? So you see that I've drawn some things and I've written some things out. So I want you to think about what it looks like. something that was done in the past looks similar to what we're doing now. So I want you to try and reach back into your memory banks and try and figure out what it is that I'm referring to. Got some light bulbs that have gone off already. Alicia and then Eric, what were you thinking of? Okay, what were you thinking of? Say, distributive property. Yeah, in fact, that's exactly what we're doing. Now, I feel confident in saying that my students in this room right now are experts, Jedi masters of the distributive property. So now it's just a matter of raising that level of complexity up with it. Okay? So you're going to see this example work through step by step. So it's not like I'm going to expect you to be able to do this right off the bat. Excuse me. Sorry for the interruption. So, as I always do, you're going to learn step by step, but I wanted to give you an overview of what's going to be going on. Here's another example of something you're going to be doing today. Multiplying polynomials. This time, I'm multiplying a binomial times a binomial, and I'm using a special method that you're going to learn today called FOIL. Okay? And I've completed the entire question. And you're not copying it, you're not doing it right now. The idea is to just get a perspective. Okay? Any questions so far? All right, so now, one particular method that works, unfortunately, it only works in one particular situation, but it's an important situation. You're going to learn within today's lesson the FOIL method. This is the kind of thing that you're going to learn today, and you will probably remember for a very, very long time. If I went around this school building and asked other teachers if they remember the FOIL method, they would probably remember something about it. Okay? What it is really is a memory device. It's a way of remembering what you're supposed to do. And it's also an organizational device. It helps us stay organized in a particular way. You have to just understand what the letters mean. The F stands for first. The O stands for outer, the I stands for inner, and the L stands for last. Here is an example of two binomials being multiplied. So now we're going to talk about what are the F's, what are the O's, what are the I's, and what are the L's. Okay? But keep in mind that what we're really talking about is the distributive property. We're multiplying things together. So the first terms are the terms that show up first within each binomial. So here's a binomial. This shows up first. Here's a binomial. This shows up first. And so what we're going to do is multiply those two together. So the 2x times the 4x. We're going to multiply them together. Any questions so far? The second word, the outer. The outer is a little bit different. Instead of just looking with each binomial, we're looking at the whole expression all together. The outer refers to what's on the outside. And the outer is the outside here and the outside here. In other words, outside of the whole thing. So this is an O, and this is an O. That's an outer, and that's an outer. We're going to multiply those two together. Anyone want to venture a guess as to what the inner will be? Based on what I've done so far? Kayla? Yeah. If these are the outer, then these must be the inner. Inside. we're going to multiply those two together. 3 and the 4x. And based on how I wrote things out, you should have a decent idea already of what is going to be the last terms. What do you think, Sharik?
The last terms of each binomial, which is 3 and -1.
That's right. And I love the way you said the -1. Very important. So those are the last terms, basically the opposite of the first terms. And so we are going to multiply those two together. The 3 times the -1. Just like with distributive property, what is really happening is you're multiplying a bunch of things, but then the results are being added. So what we're really doing is we're saying, do this, add it to the result of this, add that to the result of this, and add that to the result of this. That's the distributive property, and that's what we're doing here. The FOIL method keeps us organized, and you're going to see in a little while that there's also another added benefit to doing the FOIL method. Okay? Are there any questions so far? We are not going to finish this. We're going to do some formal examples in a few minutes, but I wanted to introduce what the letters meant and how to find them. Any questions? So now we're actually going to pause on this and come back to it in a little while. So now we're going to explore a bunch of different types of problems that you will be required to understand and know how to execute. In the first example, we are multiplying polynomials. We are multiplying a trinomial times a monomial. And quite honestly, I could have given this example to you way back in chapter 2, and you should have had a good idea of what to do. It's distributive property. We multiply the monomial times each term in the trinomial. So this is going to get multiplied times this. It's going to get multiplied times this and times this. Now this first time, we're going to write out everything. That is my expectation for you and for us together here. Once we see it and understand how it works, then we can start using our brain power to do mental math on things that we can do quickly. But we have to be very careful because there's a lot of areas where you're going to get confused. So we have to be very careful. So let's do the first arrow. -1/3 x squared. So we've got -1/3 x squared times 6x. That's this first arrow. A week from now, you'll be doing that mentally. Right now, we're writing it out. So that's the first part of the distributive property. Now we're going to add the second arrow. -1/3 x squared times 3x squared. Plus the third arrow. -1/3 x squared times -9. Now I'm going to do something and you should have an aha moment regarding the last chapter. Because what if I did this? What if all I asked you to do was, if all I asked you to do was that, where does that skill come from? Where did you learn how to deal with that? Hezekiah? What chapter? Chapter 8. And you just took an exam on it. And in fact, this class did extremely well as a whole. And the average was off the charts. I mean, the majority of the class got A's and B's. Which means to me that you should be an expert on simplifying that right now. You should. So let's find out. So what's negative 1/3 x squared times 6x? What do you get? Ania? Yep. Negative 1/3 times 6 is negative 2. X squared times x is x to the third power. And that you learned in chapter 8. Then we're going to add on the next part. So we had that. So what's negative 1/3 negative 1/3 x squared times 3x squared? What do we get there? Kamoy? Yeah, negative 1 x to the 4th. Very good. Plus the result of the last one. What do we get here? Brian? 3x squared. Now write it in standard form. Largest exponent, largest degree comes first. We've got this, negative x to the 4th, then this, minus 2x to the 3rd, plus 3x squared. Nothing else can be done because these bases are not the same. I'm sorry, the bases are the same, but they have different exponents, and when you're combining like terms, it all has to be the same, and so that is the result. Comments, questions, concerns? Okay? No comments, questions. All right, part B. (4n plus 7 times 2n minus 5. It's a binomial times a binomial. But what would happen if all I asked you to do was that? What would you do there? Marie? Yeah, so you would distribute the 7 here and here. Well, what if instead I asked you to do this? What would you do there? Catalina? Distribute the 4n to here and here. So guess what? That's what we're doing. We're distributing both. Start from the left and work your way across. So 4n times 2n. So we're going to do this first. 4n times 2n. Plus 4n times negative 5. So we're done with the first two, now the 7. 7 times 2n plus 7 times negative 5, I can just do that mentally, that's negative 35. Now multiply everything out and then simplify. 4n times 2n, what do we get as a result of that? Sebastian? 8n squared plus 4n times negative 5. What do we get as a result of that? Just 4 people can do that? If you're sitting there doing nothing, I assume you already did it, so then I'm going to call on you anyway. Tristan? I'm sorry? I just can't. Okay, I just couldn't hear you. Negative 20n. Very good. Plus, what's 7 times 2n? Stephanie? Very good. 14n. And then we've got plus negative 35. Now, like terms. We didn't have to deal with like terms in the first example, but this is something you're going to deal with a lot. Like terms. Here and here. So now we're going to combine like terms and then write a final expression. 8n squared doesn't have any like terms. Negative 20n and 14n, what do we get as a result of that? Jada? Very good. Negative 6n minus 35. Any comments, questions, or concerns about how we did that? It was not FOIL, although it's pretty much the same thing. Any questions, comments? I mean, Alyssa, we actually ended up doing it in the same order. So we basically did FOIL. But I was demonstrating it as the distributive property, which is, it's the same thing. Okay? All right, part C. Based on the 2 examples you've seen done already, you should have an instinct about what's going to happen here. So what do you think is going to happen when we have a binomial times a trinomial? Anissa, what do you think? What? That's right. We're going to distribute the x times everything here, here, and here, and then we're going to distribute the 5 to everything here, here, and here. It is quite a bit to keep track of, but here's where we're going to start being smart. We're going to stop writing out everything. Hopefully you can handle it, and we're going to do the mental math right away. Let's see if we can handle that. We're going to do the first arrow. X times 3x squared. What do we get when we do that multiplication? Ania? Very good. So one arrow's done. 3x cubed. Second arrow. X times negative 4x. What do we get as a result of that? Kamoy? Very good. Negative 4x to the second. Third arrow. X times 1. I don't need anyone to help me with that. Nor do you. So we're half done. And we used mental math. We used what we already know how to do to simplify the process. Now the 5. 5 times 3x squared. What do we get as a result of that? Tristan?
15x.
Very good. 15x squared. 4 arrows done. 5 times negative 4x. Alicia? Negative 20x. 5 arrows done. The last one, 5 times 1 is 5. Now find yourself like terms, if there are any, and simplify. Negative 4x squared, 15x squared, like terms. And then the x and the negative 20x. Combine like terms and write it in standard form with the highest exponent first. 3x to the third, negative 4x squared and 15x squared. What do we get as a result there? Sebastian? Very good, because we're adding now, 11x squared. What about x and negative 20x? What do we get as a result of that? Brandon?
Yeah, what do you get as a result of
X and negative 20x. Negative 19x. And then we've got 5. And that is the result of multiplying the binomial times the trinomial. Comments, questions, concerns, issues, anything at all on any of this? Okay, let's see how you do on your own. I would like you to multiply or simplify this expression. 2 minutes. All right, so let's see. We'll start with Kisara, Tristan, Kezekiah, and then Alyssa. Kisara, just give me the first term that you got.
5x.
Okay, who was next? Tristan? You got the same first term. What was your second term? Okay. Who was next? I lost my order. Kezekiah, do you agree with the second term? Okay. What was the third term, Kezekiah? 10x cubed. Who was next? Alyssa, what'd you get? You got the same third term, 10x cubed. What'd you get for your last term? Now, we just started, so it's okay if you made a mistake somewhere, but I just want to get a sense of how we're doing. Give me a thumbs up if you got this question. Okay? Put your thumbs down. Does anyone have any questions? If you can handle that, go ahead. I personally couldn't handle that because I need things organized, but if you can handle it and know where to put things, then go for it. Okay? All right, so now let's go back to the memory device that's supposed to help us, FOIL. And as Alyssa pointed out in part B of the last example, we basically already did it. This first time I use it, I'm going to actually write out the letters. We're going to write out the F, the O, the I, and the L. But after that, we're not going to write the F and the O and the I and the L. We're supposed to know it in our head. So, the F, the O, the I, and the L. So we were pretty good right when I introduced it. Let's see if we're still understanding. Could someone tell us, what will the F's be? What will the F's be? Caleb? Very good. So we're going to do 5x times 3x. Next time we do this, we're going to do that mentally. But right now, I want you to see it. Plus the O's. What are the O's? Alicia? That's right. 5x times negative 2 plus, what are the I's? What are the I's, Zabari? Very good. 1 and 3x. And what are the L's? What are the L's, Ania? 1, negative 2. So simplify, which we've just gotten very good at. I mean, we've done 5 of them already. So we should be able to do this quickly. So we've got 15x squared. We've got negative 10x. We've got 3x. And we've got negative 2. Here is the extra benefit of FOIL. Look at the two terms in the middle, the O and the I's. These two terms will usually, not always, but usually come out to be like terms. So you don't have to search for them. In fact, some of you are going to get so good at it that you will mentally be able to do both steps in one shot. Some of you, not everyone. So now just simplify anything that needs to be simplified. We're going to combine the like terms, and we get 15x squared minus 7x minus 2, and that is the result of multiplying the two binomials. Comments, questions, and concerns? Good, we're doing very well so far. Any comments and questions? Because now I'm going to jack up the complexity quite a bit. You're going to start hearing me say things like FOIL it and stuff like that. Use the FOIL method. FOIL. And I'll expect you to be able to casually be able to say, oh yeah, Mr. Galvin, we just need to FOIL it. Okay, that's the kind of things that's going to be going on in this room. So now I've upped the complexity by putting in a binomial times a binomial plus another binomial times a binomial. So what I've done is put in 2 multiplication problems. Here's the first one. Here's the second one. I put 2 in and then added them together. But basically, here's what's happening. We need to do that one. We're going to use FOIL, and we're going to do a lot of it mentally. We're not going to write the F, the O, and the I, and the L. We should now have that in our heads. and we just need to know which two terms to pick out. So the f's, z, 2z, so we're going to get 2z squared. So we did it mentally right away. Plus the outer, z times 4, 4z. Plus the inner, negative 3/4 times 2z. Sharif, what do you think?
Negative 6/4z.
Yeah. What does negative 6/4 translate to in a more human way?
Negative 1.5.
That's right, very good. So this is negative 1.5, oops, I got my 1, negative 1.5 z. And then the L's, the negative 3/4 times the 4. What do we get as a result of that? Alyssa? Very good, negative 3. Now, I whited out part of this just so we could focus. Let me bring the other part back. I'm not going to finish this because I have the same variable here, and I could take a good educated guess that I'm going to end up with like terms from here and here. So I want to leave this alone so I can do lots of mental math and save myself some time. So now I'm going to do the FOIL method again. Remember, they're both being added together, so we're going to add on the result of this. Z times z. Well, that's easy. That's the first terms. The outer, z times negative 2, negative 2z. The inner, 1 times z, that's just 1z. And the L's, 1 times negative 2, negative 2. And now you can see that reserving or waiting to simplify things was worth it because now we can find like terms all over the place. We've got this, 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 and that. We also have z squared and 2z squared, and we have the negative 2 and the negative 3. z squared, we get 3z squared. Done with that and that. 4z, z is 5z, minus 2z is 3z, minus 1.5 leaves me 1.5z. Done with all of those. Negative 3, negative 2, negative 5. So the result of multiplying, and then adding together is all of that. Any comments, questions, or concerns with that? No comments, no questions, no concerns. What about any of this? FOIL. Anything, its purpose. Okay? Checkpoint number 2. Let's see how you do with this. thumbs up if you have an answer, any answer at all. Okay, good. All right, put your thumbs down. Eric, what'd you get?
13x squared minus 2
Okay. Jada, what'd you get? Okay. Zabari, what'd you get?
13x squared minus 2
So I think that's what Eric had said. The correct answer is 13n squared minus 2n minus 1. So this was kind of, as far as complexity, somewhere in between the first question in the last example and the second one, because this second half was much easier, just straight distributive property. Okay? So give me a thumbs up if you got this question correct. Okay? Put your thumbs down. So we have quite a few people who not sure where you went wrong. What? Okay. So that one detail messed up everything. And so that's something I've been talking to you about since the first week of school. Positive and negative errors. Still the biggest, most common issue that we have. Maria, do you know where you went wrong? Okay, but I see you trying to figure it out. Okay, Sebastian, have you figured out where you went wrong? What was it?
It's all n squared and the n squared. I got 12n to the power. I don't know why I did that.
Okay, so you used the multiplication rules when you were supposed to be adding. And you see now why. Okay. Maria, maybe Zabari or Kamoy or Alicia can look and see if they can help you find it, or you can be plugging away yourself. It's up to you. Anyone else want to share with us where you went wrong, if you found it already? Ania? Okay. Okay, and that was just accidental. That was totally accidental. And I know you know how to do it because you've demonstrated a bunch of times today by volunteering that you know exactly what you're doing. Okay? So that's okay. Okay, Catalina? Okay, did you add it correctly on other ones and it was just one time that you didn't do it right?
No, because like on the other checkpoint, I put instead of 5 on the checkpoint, I put 6.
So you are getting some of the rules confused. Okay, so we're going to need to work on that so we can feel more confident on what you're doing. Okay? So I'll review those rules with you. Okay?
I forgot to hide it.
Okay. Do you feel like you knew what you were doing and you just forgot to put the 2? Okay, good. So that's good. So that's something that we can improve on easily. Anybody else? And thank you, my brave students, for sharing a mistake, and that's great. That's brave and that's important to be able to do. So I appreciate it. So we're doing pretty well. We have one final example where we're going to start applying this to a real world example. I'm going to put it up. There's some text you're going to need to read, and there's a diagram. You don't need to copy the text, but you need the picture on your paper. I have a computer to help me make a perfect picture. Your picture doesn't need to be perfect, it just needs to be accurate. In other words, you need the right information in the right place. So read and copy the diagram. Then we're going to discuss and actually figure it out together. So, the story here is based on reality. Reality's been stretched a little bit to kind of serve the right purpose here in the classroom. But the idea is we have a contractor, a person or a company who installs pools in people's backyards. And they might have several templates of different pools. You want an oval pool or a rectangular pool or a circular pool or a strange amoeba-shaped pool or whatever. So they have different templates, and then depending on how much space a person has in their backyard or how large a pool they want to have, they can either size up the template or shrink it down, depending on the needs. And so that's what this ratio is referring to. This ratio will keep the shape the same. So it's a rectangular pool, and it's going to have a length to width ratio of 5 to 2. That's represented here and here. The x is the factor that we will multiply by, depending on whether we need to size it up or shrink it down. Okay? So if someone's got a huge backyard, maybe they'll size it up by a factor of 10. My backyard's tiny, maybe I'll size it up by a factor of 4. And so that way the contractor knows how much space they need. But it gets a little more complex because most people don't just cut out a rectangle, put the pool in, and then leave everything else the way it is, surrounded by grass. You usually don't just walk on grass and then boom, you're in a pool. There's usually a walkway around it, and so the template has that built in. So we have a 2-meter walkway across the top and the bottom, and a 3-meter walkway on the side. And so that's the beginning of the template. Then the contractor would go a step further and create some expressions that they could use to quickly figure some things out. Okay? So what we're going to do is we're going to act as the assistant to the contractor to figure out the expression to help us do some quick calculations. And so here's what we're asked to do. To write a polynomial expression to represent the total area of the swimming pool, including the walkway. After we figure that out, then we're going to use it. Okay, that's that second step. Find the area when x is 10. So, the first thing we need to do is figure out how do we find the area of any rectangular shape. How do we find the area of any rectangle? Only 4 people in my super high advanced class? Oh, a whole bunch of people. Okay. Jada? Base times height. Length times width. One side times the other side. However you want to say it, it doesn't really matter. But now we need to basically work out that information. So let's start with the base. What is the base? Well, we're including the walkway, so we're going to go from here all the way to here. So how can I represent that distance? That total distance, what will it be? Well, the total distance will be from here to here, then from here to here, and then from here to here. So what will the total distance be? Brandon? Good. Now mentally simplify that. 5x plus 6. Very good. 5x plus 6 is the base of this template. Now the height. The height is going to go from here to here. So that will be the distance from here to here, from here to here, and then from here to there. So what will the total height be for this template? Hezekiah? 2x plus 4. Let's go back to Jada, who answered the first question. Jada, remind us again, how do we calculate an area of a rectangle? Base times height. So hopefully your instincts were kicking in and telling you what was going to happen. So now we've got the base, which is 5x plus 6, and the height, which is 2x plus 4, and we need to multiply them together. How are we going to do that? What would be an effective way to multiply them together? Zabari? Foil it. So, let's foil it and use our powerful mental math to help us. Let's do the F's. Could someone tell me the result of the F's? Tristan?
10x squared.
10x squared. Very good. What about the O's? Someone can tell me the result of the O's. Kezekiah? Very good. What about the I's? What will the I's be? Kamoy? 12x. And the L's? Sharik?
24.
24. Combine like terms, and then we will have an expression that we can give our boss, the contractor, that represents the area of this pool plus walkway, no matter what size we want to scale it up to. This can be used over and over again. So now we have a customer that would like their pool to be times a factor of 10. So now we take that 10, plug it in everywhere there's an x, and simplify the expression, and then we know exactly how much area we need in that person's backyard. You got a question, Kamoy, or you were going to go ahead and tell us what it worked out to? Okay, let me just get it down, and you will be the first person I call on. But here's what it looks like when you plug in the 10. Just to make sure we're all looking at the same thing, I plugged in the 10 for x right there, 10 for x right there. Simplify everything. You did all of it? Or just pieces of it? Okay, so what'd you get? Yeah, when you simplify all of this, you get 1,344 square meters because all the measurements are in meters. So that means that if that's the decision that the homeowner made, then the contractor would then have to go out and make sure that their backyard could fit something of that size. Because the entire project is going to take 1,344 square meters. That's really big, by the way. So, are there any comments or questions? Comments, questions on how we got from this diagram to this multiplication problem, then to this number? Any questions?
I got the excellent.
Okay, so you figured it out? Excellent. Good work. Any other comments, questions? Okay, we're doing extremely well. Draw a line across your paper. Your classwork is going to be on page 93. Going to do 21, 19, 18, 16, 13, 11, 5, and 3. All right. So today we jumped up a notch in complexity, introducing multiplication of polynomials. Let's see how we're doing so far. Please keep in mind that this is still part of the learning process. If you're making mistakes, that's okay. The idea is to learn from them and figure out how to do a little bit better. But let's see how we're doing. Number 21. The expression that I was looking for the total area was 4x squared plus 22x plus 30. And then if you have the width of 1.5 feet, that comes out to 72 feet. Number 19. The total area is 3x squared plus 15x. Number 18. 2m squared plus 5m minus 41. 16. 4a squared plus a minus 1. 13. W to the third plus 5w squared minus 23w minus 3. 11. Negative 6d squared plus 23d minus 10. And finally, number 5. 2y squared minus 7y minus 15. Oh, and I'm sorry, and number 3. Negative 8d to the fifth plus 20d to the fourth minus 24d to the third plus 8d squared. So there was 8 questions. 6 out of 8 would be 75%, and that would be a decent starting point for now. And then we would hope for some improvement as we learn from our mistakes here, and then also do a little bit more practice with homework. So, comments, questions, concerns on any of these? Brandon? I'm sorry? 21? Of course. Let's survey first. Give me a thumbs up if you got number 21 correct. Put your thumbs down. Okay. Good. So let's take a look at number 21. So we're working with area again. It asks us to write a polynomial that represents the total area of the flower bed and the border. So basically, we're being asked to do this. So, well, didn't work out as well as I wanted, because it's not a square. Do that again. We're trying to find that total area. So, what if instead of this complicated looking diagram, we just use this? So Jada helped us during our lesson with example 3 with regard to finding the area of a rectangle. She taught us that it was base times height. So we need a base, this distance here, and we need a height, this distance here. So let's start with the base. What is the total distance from here to here? Moy? It is 2x plus 6. I feel confident in saying that there's quite a few people in here who put x plus 6. Give me a thumbs up if you put x plus 6. Good. You got tricked. Okay? Now we need to learn why it's 2x plus 6. Come on. A lot of your classmates put x plus 6, but you correctly put 2x plus 6. Where did the other x come from? Yeah, because this is also over here. Just because it's not marked doesn't mean it's not there. And there is where you got tricked. Okay? Because if you only did x plus 6, then you only found the area of this shape. You did not include that. But now, you should be able to see that, oh yeah, there's supposed to be an x right there. There's an x right there. And that's where the 2x plus 6 comes from. So Brandon, since you were the one who asked, you were the brave one who asked, now that you see that, can you now tell us what the height is going to be? What did you put originally? You put x plus 5 because you got tricked there as well. Of course, that makes sense. If you got tricked on one side, you're going to get tricked on the other. Right here, there is also another x. So for most of us, therein lied the problem, is misinterpreting the diagram. Remember, you're going to be challenged. You're going to be asked to include things that no one's telling you are there, but you have to know are there. So I don't blame you for making a mistake. I don't blame you at all. But now we need to learn from the mistake and be aware that this will happen again. You'll be given a diagram with information that's implied. Implied means you know it's there, but no one's telling you it's there. Okay? From there, multiply. Base times height. How do we do that? How do we do that, Hezekiah? FOIL it. You can already see what the result is. The result is that. Does anyone have any comments or questions on this? Hezekiah and then Neil. Okay, so you got this. Okay, but you guys somehow went wrong with the 1.5. Okay, so that's just working with numbers, and I can come look and see what you did. But here's what you should have done. 4 times, and I'm thinking maybe this is where the mistake is, 1.5 squared. That's squared, so you have to square that first, then multiply times 4. Plus 22 times 1.5 plus 30. So once you go ahead and retry it, now that you're seeing it the way, because I can tell by your reaction that you forgot the square, right? Ah, but you can't do that, right? Okay, Ania and then Jada? Same thing? Okay, do you see it now? Or you're going to retry it right now? Okay, good. Jada? Yes, and guess what? So did about 10 of your classmates. And I have this on the board. It's actually been on the board the entire day. This right here sums up the major issue. And I'm going to talk about this in a couple of minutes after I wrap up here. Okay, any other questions on any other classwork problems? All right, your homework. It's page 583, numbers 8 through 42 even. number 50 and 52. It's a total of 20 questions. You've got 2 days to do it. You're going to read the next section. Very important. You are going to have a quiz, and make sure you write this down carefully because it's not the normal way, the normal results. You're going to have a quiz on Tuesday. On Tuesday, and that's going to be on 9.1 to 9.3. We've done 9.1 and 9.2. We will be doing 9.3 on Friday. We will go over the homework for that on Tuesday. I will be seeing you on Tuesday. And you will have a quiz on Tuesday.